It's been one of those days. I saw a few of you that did not have your homework done, so I'll go ahead and open it really quickly. But we're going to go to our calculator anyway, cool kids, right? Let's first of all talk about, shading. How do you guys get your calculators to shade in general? I'll put in the equations that we have from this word problem. That's okay. So our equations are going to be 140 minus 0.00002x, right? I typed it in, okay? And then 80 plus 0.00001x. Okay. But if you were to look at, let's just play with our shading right now. One way that you could go about doing this is you could go ahead and actually, on some of the newer calculators, I think you can actually, like, when you go to the equal sign, there are ways of changing that on some of the newer ones. Most of your guys' calculators, actually all of yours, you could go back here and you could do something like, hey, let's shade, oh, that's bold. You could do this little triangle, and this little triangle is shade up, which you could think greater than. And then if I was to hit it again, that little triangle down below means shade below. So if I was to go to the graph, you're not going to see much because this is kind of a boring graph. But we could go ahead and, let's see, zoom fit maybe? I'm not sure if that's going to be a nice one. That's kind of gross. Window, I know it needs to be above 140. I'm going to go down to -20, and let's go up to something like 200. Okay, we can see it a little bit better, but remember this downslope is super minuscule, so you can't even see it. But we can see our two little lines. So the little, remember, the triangle down is your shade below, the triangle up is your shade above. But is there another way? And the answer is yes. Sorry, hold on. Hello? Oh, hi.
It's too small.
She was in here. Oh, no, she was doing Krispy Kreme with the juniors. She's doing singing grants at lunch. But she was doing the prom fundraiser for the junior class. You're welcome. Bye-bye. What was I talking about? What was the other way of doing it? You guys found another way, right?
Apps.
Okay, so if we go to the apps, then where do I go? So let me get this back to the normal line. There we go. So then apps and, do you guys know you can just jump there with the alpha button, right? And then you can do the, where's I? There he is. Inequals. Did you see what I did there?
Yes.
Use the alpha button, you can jump places. Okay, never mind. You guys are cool and I already know that. Now what?
I'm on the graph.
Ooh. They're little or equal to's, or little less than's, or little greater than. So I can go ahead and now, guys, these are for the button. So you could hit the window button. Oh, that didn't work. Why? Is it alpha?
Alpha.
Oh. Alpha. Look at what it did, though.
Dotted.
Didn't it just do the shading for you? With the dotted and then the little triangle below? So, I mean, is it cool? Yes. But it also kind of gets in your way to some extent. For instance, if you did want to do like some sort of nifty fraction, you know our cool little alpha tricks? I guess maybe you can still do your alpha tricks. Oh, no, you can't. But you would have to go back to the equals, and then you can change that equals if you turn on the inequals. And then you guys see the little or equal to, or the greater than or equal to. Everybody found it okay?
No.
Oh, apps.
Apps and then what?
And then hit alpha, I, for inequality. I think it's the x squared button. And then it should be inequals. Uh-oh, is it not there?
Yeah, it is.
I don't have
Thomas's app doesn't have it. Dean, you find it?
Yeah.
Oh, you're just playing with it? Yeah. Okay, so that's another way to do it. It is a cool way. It's up to you. You can turn it off at any point if you want, or you can leave it on. That's okay too. I don't like mine being busier than normal, so I don't like it on, but if you want it, you can. Okay, but that's not the point of this problem. The point of this problem is to find this. I don't even think it's called the breaking even point. What's it called if supply equals demand? There was a word for it. It was in that example in the book. Sorry, it's been a long time since I did econ. Supply and demand, is that the margin? Did I find it? Page 513, if you have your book. Page 513 would have been a great place to look for this problem because it's called, you guys don't look at your book, applications. It's called the equilibrium point, the intersection. And it shows, hey, guess what? This business application thing, using, or a practical application of our systems of inequalities, says that wherever or whenever supply and demand meet, which would be this point right here, it's called the market equilibrium point.
That was close.
Oh, close. Now it's even worse. Wow.
Where's it going?
I don't know why it's so often. I give up. Oh, there it is. That's like leprosy up here.
Oh.
It's not going to erase that.
Okay. This one is called the market equilibrium point. Okay, that's the market equilibrium point, and then it shows us the following. It says, hey, guess what? This market equilibrium point, if you draw a line at y equals whatever constant height that is, whatever is above it would be the consumer surplus, and whatever is below it is called the producer? Yeah, producer surplus. And that kind of makes sense because if your demand is higher than your supply, there you go. When your demand is higher than your supply, if this is the market equilibrium point, then whatever extra demand there is extra consumers that want to get it, and whatever extra supply there is, the producers have a surplus. So anyway. We're not going into all the, well, long story short, look at page 513. I just realized this is an application to econ. We're not going over supply and demand and all that stuff today, but this is an application in business. Remember we said that pre-calculus is pre-everything future math. So then when they asked us to find the consumer surplus and the producer surplus, long story short, we had to find that equilibrium point. Could we have played with the zoom all day long and tried to figure out when will these two graphs hit? And the answer is, yeah, I suppose so. We could have played with this. And then like, well, they don't seem to be hitting anytime soon. So we could have gone ahead and tried to make our window something crazy far as our x value, our x max, just to be safe. I don't know, let's make it something like 5,000. Or should we get 50,000?
500.
500,000? You guys see this fitting? I don't understand. Ay.
It's just trying to do.
It's being difficult today. It's like a teenager. Anyway, so. That was funny though. Hey, look, it hits. Can we find the intersection point? Yeah, we can. We can go our second, and we can go our trace, and we can go our number 5. And there's a hit, first curve, second curve, guess. Doing it again. The intersection point is at, let's see, x is 2 million, but y is only 100, so y equals 100 is our line going through our equilibrium. And so any area above 100 and below the demand curve is going to be the surplus, and any area above the supply and below y equals 100 will be the producer surplus. Does that kind of work, Patricia? Mm-hmm. Okay. All right, cool kids. With that, beep, beep, beep. Section 7.6. Is there anybody struggling with their calculator as I come around and you guys are starting on notes? Yeah, let me come back and see. Is everybody else's calculators we're doing all right?
I got it. I figured it out.
Oh, it works. You're the one with the colored screen. Alright, let's go and pass your test corrections back to Eileen. Anybody who still has theirs, she's going to go over to the folder. Don't worry, she'll pick up the ones that are not being passed back. But any other test corrections, pass them on back. You pass them over. She'll get them. Oh.
Prime at 10 million. Prime was.
No, I wanted to ask her a question.
Ask me a question.
Yeah.
About what?
The bonus. Like, it is really.
The next vector diagram.
I'll teach you the bonus.
Huh?
You don't have to do the bonus on this one.
I'll teach you the bonus.
Hey guys, we're writing notes, right? Not just goofing off, because notes run to
What does this say in that left margin?
left margin. Optimization. Optimization. Did anybody else's calculator not have the inequals in there?
Like the.
Oh, yeah, yours. Anybody else's?
Oh yeah, I accidentally.
My actual calculator does.
Bring your calculator back. I'm trying to update the vectors. Because I can't update the operating systems and everything but David's
So
students.
much more convenient.
What is it in my mouth? I swear.
I should
Aaron,
probably
copy your
take
notes.
this or break.
Thomas, copy your notes.
It's not irritate me, that's why.
Come on, distraction.
Sorry.
Oh, no, you have to.
I'm gonna go to abscess.
How you guys set it as a dress
I can like set my operating system. Because it's u squared plus a squared. So then you look at m squared is 4. And then d equals
That's funny when I screwed over the whole class.
Mr. Cherry, there was the first one.
That was from
I just did like every sophomore conversion.
But I mean, the thing, reason why she said
I told you it's awful. Okay, because I ended up second score on my SAT. It's funny, but it's awful. Great. Everybody community.
We're about to get stinking. 22% done. Let's see if we can get it. Alright.
If I get a perfect score on my SAT, I'm
Alright, kiddos. Take a quick peek. I'm going to actually orient my pens because as you guys can tell, it's horrible today. And as I orient my pens, just take a quick peek at something that you haven't written. Like get yourself a line ahead because otherwise it's going to be gone for a couple moments. Looking ahead?
Yes.
Anti-dramatic.
Oh, there it is.
Yeah.
forgot.
Well, I just kind of like get used to it being off, but that was really bad.
It's not working. Mr. Chair would like stab his board.
What?
Mr. Chair would like stab his board every time.
My favorite thing Mrs. Reed did, she wrote on the board with one of the...
Oh, with the expo marker, it doesn't come off. Please don't lose it. That was so funny, that was a random place. Mrs. Reed, that's not that.
Use like hand sanitizer.
I love it because it's just a big
No, it's a
mark
smudge, it
now
doesn't
on
come
the
off.
board.
Is that the smudge?
That's why there's a
smudge
smudge on the
because
board.
you accidentally did
It's just little queens. Stop. You're right.
love this.
You guys have it?
Why do we pronounce her Regan and not Regan? Go call her Mrs. Reagan, see what happens.
George Corey tries.
Yeah.
You
That was
get
super angry. It's like her biggest pet peeve.
I don't think they were related to Ronald.
She makes that very clear.
Maybe Nancy.
Maybe Nancy. Doesn't make
Are
any
you
sense.
in on
I mean, like, they should pronounce it differently, so it could be the same.
Well, here's the real question, why did they pronounce it Reagan?
Exactly.
Alright, optimization, super cool, super important in calculus. We've actually already done a little bit of optimization this year because parabolas, we had that worksheet with the vertex and the max and the min. We had to like complete the square and all sorts of stuff. So we have done maximums and minimums this year, but we did it with parabolas only. Now we are going to say, hey, you know what, you can actually find maximums or minimums even of systems of inequalities equations. Even of systems of inequalities equations, which is kind of a crazy idea, because guys, every time you would shade and have like an entire region of overlap, there were infinitely many solutions in there. Why were there infinitely many solutions in any overlapping region? Yeah, decimals, basically. Because in any region, any point that you could draw would be a solution, right? How many points can you draw in any region? Infinitely many. Now, I mean, practically with your pencil, are there infinitely many before you would basically cover it all? No, there'd probably be a finite number. But decimals go way smaller than our pencil could ever put, or could ever show, right? So in between 2 and 3, there are infinitely many numbers. In between 3 and 4, now different kind of infinities, countable and uncountable and all that sort of stuff. But long story short, it's a crazy idea that if there are infinitely many solutions in any overlapping region, how on earth could there be a max or a min, a very highest and a very lowest? And long story short, there can be a very highest and a very lowest because our regions are bounded, and they're bounded by vertices. If you're a highlighting, starring kind of person, I would highlight or star that phrase right there. An optimal solution, aka what they want, the max or the min, an optimal solution, whatever they want, a max or a min, will always occur at a vertex. Doesn't mean it can't occur anywhere else. There's a special way that it could occur on another boundary, like on a boundary line, and not just a vertex, but the max or the min will always occur. The max or min will always occur at a vertex and maybe another boundary point, or 2 or 3 or as well. So here's a long story short. Well, if they want us to find the max or min, and if we know the max or min is going to always happen at a vertex, test the objective at each of the vertices and say, hey, the highest wins is the max, the lowest wins is the min. So all we have to do is test the objective function, test what we're trying to find the max or min of at each of the vertices. And that's basically the entire section. So, let me give you a few steps. Number 1, sketch the region of the system of constraints. Long story short, sketch the system, all of what we did in section 7.5. Sketch the inequalities, but you might have to read a problem and get your system before you can sketch it. So maybe from words you have to get systems, and then from the systems you have to do the sketch, and then you have to say who are my vertices, and then you have to test it. But long story short, figure out the system, sketch it, find the vertices of the region that we kind of talked about last section, test each of the vertices in the objective, and then select the one that they're looking for. The highest, max. If they're asking for the max, pick the lowest if they're asking for the min. You guys ready? Well, this one's nice, because they gave you the system. They didn't give you words. They didn't give you all the stuff you had to translate and figure out, or some real-life scenario with some candy-producing company. It's Valentine's Day, we'll use that as an example. They gave me equations. And they said, find the, as you're writing, find the max. That's our objective. That's our goal. Find the max of what? Of this guy. When he is subject to the following constraints. You could think of this in terms of business, find the maximum profit possible when we have all of these extra variables. We have this cost to take into consideration, we have this payroll to take into consideration, we have this. So that's kind of what's going on as far as practical application. Find the max of that objective subject to the following constraints. Now, as you guys are writing, I'm going to get y by itself, because if we have to use these constraints, we have to graph these constraints. So I'm going to go ahead and say, okay, x is greater than or equal to 0. Pause and consider, why did I just take all 4 of those and rewrite them? I can graph mx plus b a lot easier. Has anybody checked my solving for y? Does it look good? Why did this become a greater than or equal to? I divide by the negative. Does that make sense? Kiddos, what did I just say is always going on when you see these two guys?
Wait, why isn't it negative?
It's 1 minus x divided by a negative. Or you can think of adding the y and subtracting the 1. That's easier in my head. Sorry, these two just mean look in quadrant. Yeah. So I can say, okay, I'm just looking at quadrant 1. If it's okay with you guys, we're only shading in quadrant 1. Is that okay? Okay. And then when I go to graph these lines, now I have this guy, who's going to have an intercept of 2, and then go down 1 over 2, down 1 over 2. I'm only looking in the first quadrant, so is it okay if I just graph that part? Is that cool?
Yeah.
Because if I go anywhere else, it's out of the first quadrant, so forget that.
4, 0. Where it down across the
Oh, down 1, sorry, yeah, I wasn't marking, my bad, 2 and 4. Thank you. And that would just be 1 and 2. Am I shading below or above? Just first quadrant, so who cares about the rest? I'm going to go get this guy. -1, so that's down here. Then up 1 over 1. Up 1 over 1. Oh, hey, they cross. Technically, I don't even need to graph that part. I just do because it's easier to connect the y-intercept with the rest of the points. I'm shading how?
To the right?
To the, no, careful, above, greater than or equal to, would be higher than the line. Does that make sense? If you want, you can always test a point, like 0, 0 is above the line, these other points would be below. 0, 0, 0 is greater than -1, true. So I'm going to go above. I'm only shading in the first quadrant. Because this is 2 and half, that's 1. You're welcome. My overlap, you see it, right?
Yeah.
Okay, so when I get my overlap, I'm going to go ahead. I like using my little yellow marker, I don't know why. Do you guys see what the vertices would be of this region?
Yes.
Right? I have this guy right here, 0, 0, because he's the edge of the quadrant 1. Now hold on, I'm going to write them, and for a very important reason, because I need to test each of the vertices. So I have 0, 0. I have 1, 0, right? I have 0, 2. And then I have 2, 1. Now how could you, I mean the picture looks like 2, 1, how can we double check that's a solution? Plug it in, good. If I plug in 2, 1, 2 equals 1, that works, and then 2 equals 1, good, yeah. So I have my entire region. Now, guys, look at your steps. I sketched it, I found the vertices, and now what do I need to do? Test each one into the objective. Meaning, sorry, that's a J. Plug into Z. Plug in 0, 0. Well, 3 times 0 plus 2 times 0, isn't that just 0? He's kind of low. I'm trying to find the max. Plug in 1, 0. 3 plus 0 is 3. Plug in 0, 2. 0 plus 4 is
1.
Plug in 2, 1. 6 plus 2 is, who's my winner chicken dinner? The winner is 8, but who is the point? So this objective, I can have a maximum z of 8 at or when the point 2, 1, which I could go a little bit further and say x equals 2 and y equals 1. Do you guys remember how we answered this with the parabolas? The maximum of is the value, and the at or the when is the condition that made it true. Now, back then it was like the maximum was the y, and the at or the when was the x, but in this case, my maximum is this guy that I'm trying to find the max of. I'm trying to find the highest, and it is the highest at 8. So that's the highest it goes, and it goes to 8 when I have the point 2, 1. I'm plugging into this guy.
Oh.
So I'm taking each x and plugging in, and each y. So then I plugged in 2. 3 times 2 is 6, plus 2 times 1 is 8. Does the process make sense? Okay. So this is basically the entire section.
So you're basically grabbing whatever the
The corners, the edges of the overlap. Good. And then I'm plugging into whatever I need to. So does it get any different? That's just showing the picture. That's just showing the picture. We did it right. We did it right. Don't worry. I think I just showed plugging in, but I think we understood. They just wanted to prove the point just a little bit. So then, even though these are the vertices, plugging in 0, 0, 1, 0, 0, 2, you don't have to write this down, but check it. They said, well, what about 1, 1? That could be higher. It's not, though. What about 1, 1/2? That could be, how about 1/2, 3/2? That could be, they just plugged in all sorts of random points and said, guess what? None of them are ever going to go above 8. 8's the highest it happens at a vertex. Okay. Now, what could change? Let's go here. I didn't want that. Single page. Struggle. I want this guy. Okay. It is possible for the max or min to occur at 2 different vertices. That's a good idea. It's another example. It's another example, but it's a quick, unusual characteristic. What's something weird that could happen? Something weird that could happen is the following. This is our objective. Looks a lot like the other one, right? This is our objective. And we could make the system of equations if we needed to. Technically, the system of equations as far as the restrictions for this region right here would be, let's see, first quadrant, right guys? So x greater than or equal to 0, y greater than or equal to 0. We have the line, for some reason, they cut it here. So they have the line y is less than or equal to 4. For some reason, they're going below 4. For some reason, they're cutting it at x needs to be less than or equal to 5. I don't know why they're cutting it there, but they are. And then there's one more boundary, this guy. Now the weird thing is, man, they didn't give me an equation for that guy. How am I supposed to know who this guy is? Can we ever find the equation of the line given 2 points? Yeah, we can. So then even if we needed to find the system, there technically is one more equation that needs to be included. The struggle is I need to figure out what that line is that I'm needing to be less than or equal to. I would be able to do y is less than or equal to m. Well, m, aren't I going to go down, what, go down 4? And go right, am I going right? Down 4, right 3?
Yeah.
That looks right, right? Down 4, right 3. Have fun. Should have somebody record it. It'd be so cute. They get to go do a singing grant to Mr. Tooley's class. Was it for Mr. Richmond? Is this Richmond John? That's Jackson. Guys, how am I going to figure out my intercept though? How do I figure out my intercept?
You can plug in.
I could plug in.
X0.
Yeah, do you want me to plug in? Well,
Correct.
but I don't know who he is. I could plug in a point though, couldn't I? I could do point slope form, I was just being lazy. I could plug in when x is 5, what's y gonna be? 0, right? Ew, I don't like 5. Is that any better when x is 2? That's even worse. Struggle. Alright, fine. Y minus 4 is equal to negative 4 thirds x minus 2. This isn't pretty, but we'll get there. Negative 4 thirds x, that's going to be 8 thirds plus 4 is 12 thirds. 8 thirds plus 12 thirds is 20 thirds. There we go. Okay, long story short, I have my big old nasty system of constraints now, right? But I had the picture all along. The long story short of this was, okay, hold on, if they gave us the picture, what are we supposed to do with each of our vertices that we can very clearly see? Test them all, right? So they already started plugging in 0, 0, and 0, 4, but don't we have 3 other ones to plug in? Okay, so what happens when we plug in the rest? Keep plugging in the vertices. We didn't actually need to find the system. I was just showing you that we could find the system if we needed to. We got to plug in the rest. So when we plug in, so we're plugging out each of the vertices, right? So we plug in, they plugged in 0, 0. This is our objective. What happens when I plug in, what's another one? 2, 4?
12.
12. What happens when we plug in 5, 1?
12.
What? What happens when we plug in 5, 0?
10.
Who wins? How is it possible that 2 of them win?
They're on the same line.
Unusual characteristic.
Yeah, exactly. It is what it is. The highest that this thing can go is 12. So it's going to be a maximum value of 12 on I'm coming to you, Thomas, hold on. So the long story short, guys, is if it ties, it's going to happen at both those places, and to be honest, it's going to happen at that entire boundary line. Because every single solution, this could be rewritten to be y is equal to mx plus b, and it's basically talking about the lines and which line is going to get the furthest out with a certain slope. And so this entire line, every single one of these is a solution. So the long story short, did we find the max at a vertex? And the answer is yeah. We found it at 2 of the vertices. The max is 12. Done. When does it happen? There. Yes. There. Yes. Everywhere in between. Yes. The only reason why, though, is because for this particular example, the line of the solutions happens to be exactly falling on that entire boundary. But you don't really need to stress about this too much. I'm not going to go too deep into it. The long story short is you will always find the max at a vertex, and sometimes it happens at more than one. Thomas, I answer it kind of.
Last part, why is that?
Oh, because it can't be the whole line. It's only the part of the line that's in my kiddos, the one thing we can get to is what if there are words? Let's see what you can do. Just take the words to make a system, and then graph and then shade. You can use your calculator. I guess. Yeah, I need to be calculated. Like substitution, elimination. Word problem.
I bought like 30 pounds.
Bye guys, happy nutrition.
Let's go, Andrew.
Both of those? Does it?
No.
Yeah, 2.
We have to do something.
I know you have to.
I did about half of it.
How much it is to like get that extra credit?
I didn't get it. No, oh no, I don't.
What?
You guys see Becca? I have her calculator. I lost her.
Are you sure?
Sounds terrible.
You were right here and you're like, yeah.
Well, if you attempted it, you have to do
I miss the.
it. You didn't attempt it.
But you still have the correction, you seem to be.
Okay, so I didn't go through. Yeah, she did. She's okay.
Like, I mean, if you see the bonus as being.
I use cow instead of pie. Nobody uses cow, you gay. Exactly. But it makes more sense. Maybe it makes sense for 2 by 1, but not for 1 hour.
I mark off the bonus. This one though, that's what Ellie got.
Miss D, that was kind of rough, but
It was a big whistle. It was she went through.
we went, we, we're still recording this thing, you know.
Yeah.